Here we will discuss question number 42 of K 2018 Civil Engineering afternoon session. Question is, 4 bolts P, Q, R and S equal diameter are used for a bracket subjected to a load of 130 kN as shown in the figure. The force in bolt P is to be calculated. There are 4 options available. Now student has to solve this particular question within 2 minutes. So difficulty level is somewhat difficult since calculations involved are somewhat complex than others. Now here given parameters are, this vertical distance between two bolts is given 240 mm while horizontal distance between bolts is given 100 mm. This load is given 130 kN and distance from center line is 200 mm. So that is the load 130 kN, eccentricity is given 200 mm, number of bolt 4, vertical distance is 240 mm and horizontal distance is 100 mm. So if we wish to calculate a force in the bolt due to direct load, that will be equals to load divided by number of bolt. So load equals to 130 divided by number of bolts, there are 4, so that is coming out to be 32.5 kN. Similarly, we can calculate force in the bolt due to moment. Now that is equals to P into eccentricity, load into eccentricity divided by Rp divided by summation of Ri square. Now here Rp, that is the distance of bolt P from the CG. So that is equals to this square root of 50 square plus 120 square. So 50, that is 100 mm divided by 2, while 240 divided by 2, that is coming out to be 120. So this is how 50 and 120 is to be calculated, and Rp is coming out 130 mm. Now we can see from the figure that bolts P, Q, R and S are at equal distance from the CG. So we can say that the distance of bolt from CG for all 4 the bolts, that is P, Q, R and S, so that is equals to 130 mm. So we can say that Ri equals to 130. So if we wish to calculate summation of Ri square, which is required to calculate force in the bolt due to moment, we already calculated Rp, that is equals to 130 mm. Load is given, eccentricity is given, Rp we have calculated. Now the only part is summation of Ri square. This is for this particular formula of force in the bolt due to moment. So summation of Ri square, that is there are 4 bolts multiplied by 130 square, that is equals to 67,600. So lastly, if we just put this value in this formula, so we will get 130, this is the P, then eccentricity, then this is your Rp, and lastly summation of Ri square. So this is equals to 50 kN, that is F2. So we have calculated force in the bolt due to direct load as well as force in the bolt due to moment. So these two forces are required to calculate a particular force in the bolt. How to calculate that? So that is resultant force Fr. The formula to calculate is equals to summation of F1 square plus F2 square plus twice F1 into F2 multiplied by cos theta. So cos theta, that is equals to, from that particular figure, if we just take from CG the distance, so we will get theta equals to this horizontal distance, this is your horizontal distance 100 mm divided by 2, and we already calculated Rp, so that is 130. So that is hypotenuse. So we'll get cos theta will be equals to 0.3846. So from there we can easily calculate if we just insert the values of F1 and F2, and lastly cos theta. So F1, that is force due to direct load, and F2, that is force due to moment, we have already calculated. So if we just insert this value, we'll get 69.32 kN. That is the final force in the bolt, 69.32 kN. So option number B is correct. So if we just look at the calculations again, so here we have to calculate it, force due to load, force due to moment, and then we have to calculate particular angle cos theta. From there we can easily calculate resultant force, that is Fr, which is to be equals to the force in bolt P. And for that we required particular horizontal distance between bolt, vertical distance between bolt, and the load which is subjected on a bracket. From that we can calculate, we can solve this kind of question.